Welcome to our AI for Everyone instructional video series. This instructional video series is developed by the American Institute for Professional Training and Development, a nonprofit organization. This educational video series is designed to provide an opportunity to learn about AI and explore how to benefit from this remarkable technology. The entire series is available for anyone to view at no charge. My name is Sandy, and I will be the AI avatar guiding you throughout this presentation, where we will be learning about large language models. You've probably already been using them if you have chatted with ChatGPT, Claude, or Gemini. But what exactly are they? How do they actually work? Together, we'll take a brief journey into the mechanism of how they work, from how AI reads text, to how it generates every single word of its response, to why it sometimes confidently says things that aren't true. Here's the first thing to know. AI doesn't read words. It reads tokens. Look at that sentence on screen. The quick brown fox jumps over the lazy dog. A human reads it as 9 words. A large language model reads it as 10 tokens, because jumps get split into jump and the letter S. That's how subword tokenization works. Common words become 1 token, rare or complex words get broken into pieces. On average, a token is about 3/4 of a word. Claude 3.5 can hold over 200,000 tokens in its working memory at once, roughly 150,000 words. Every token generated takes about 1 to 2 milliseconds of compute, and a typical LLM tokenizer knows over 100,000 distinct token types. This isn't a technicality. Understanding tokens is the key to understanding why large language models behave the way they do. As you probably already know, LLM stands for Large Language Model. Let's unpack each word. Large means billions of parameters trained on trillions of words. The large scale is what enables the capability. Language, it understands and generates human language, not just English. It can handle dozens of languages, code, mathematical notation, and more. The word model refers to the statistical system or model that predicts text. Here's the key distinction that trips people up. An LLM doesn't look up answers from a database. It doesn't retrieve pre-written text. It actually generates every single word fresh, predicting the most useful next token given everything it has previously seen. Think of it this way, as the world's most well-read autocomplete, one that has read the entire internet and can finish any sentence with uncanny fluency, but always by prediction, never by retrieval. Before an LLM can process text, everything has to be converted to numbers. Let's look at the sequence in the pipeline. First, raw text comes in, just the sentence you typed. A tokenizer splits it using a dictionary of known patterns, words, subwords, and punctuation. Each piece maps to a token ID, a simple integer. Hello might be 9,906. A space followed by world might be 1917. Each token ID then maps to an embedding, a long vector of floating point numbers that encodes the token's meaning and relationships to other tokens. And finally, all those embeddings are fed into the transformer layers, which process them all in parallel and predict the next token. It's like translating a text message into a secret numeric code, then running that code through a very sophisticated pattern matching machine that knows how sequences tend to continue. Now let's examine the core mechanism. First, you may ask, the capital of France is... The model then generates a response token by token. At the first token, it looks at the full prompt and considers every possible next word. The probability table on the right shows what it's doing internally. Paris gets 87% probability. Lyon gets 5%. Situated gets 3%. Everything else is noise. The model picks Paris. Then it adds Paris to the context and asks, what comes next? And repeats. Every single word of every response you've ever received was generated this way. Now let's talk about temperature setting. At low temperatures near 0, the model always picks the highest probability token. Predictable, factual, consistent. At high temperatures, it samples from less likely options. It becomes more creative, more surprising, but also less reliable. Everything you see on screen represents the model's context window, that is, its entire working memory at any moment. The system prompt is set by the developer. You are a helpful assistant. Be concise. This shapes every reply. The conversation history is every prior turn in the chat. The model rereads all of it every single time you send a message. Your current input is the new question you just asked. And as the model generates its response, each new token gets added to the window too, consuming space. Here's the critical constraint. When a conversation exceeds the context window memory capacity, the oldest messages simply get dropped. The model doesn't summarize them, it doesn't even remember them. It loses access entirely. This is why very long chats can seem to forget things you discussed at the beginning. Large language models, or LLMs, are truly remarkable, but they do have real limits. Let's look at both the strengths and limitations. When it comes to strengths, they can generate fluent, grammatically correct text in any style. They can reason through multi-step problems and explain complex ideas. They follow complex instructions reliably. And one model can write, code, translate, and summarize large documents. As far as limitations go, well, they hallucinate. They can generate confident, plausible-sounding information that is factually wrong. The context window is finite. Very long inputs get truncated. And training data has a cutoff date, so large language models don't know about recent events. At least for now. Knowing these limitations isn't pessimism. It actually helps you in learning how to effectively work with large language models. Now for our 3 key takeaways. Number 1, large language models work with tokens, not words, but subword units that map to numbers, then to embeddings that encode meaning. Number 2, every response is a next token prediction, repeated until the response is complete. Temperature controls determine how creative or deterministic the output will be. Number 3, the context window is the model's working memory. It is finite in capacity, and when exceeded, it simply forgets without warning. Thank you for watching. I hope that you will join me in our next instructional video where we will be discussing what is a token.